What's up, algebra? Today we are going to get started on the Pythagorean Theorem. Okay, so the Pythagorean Theorem basically is only used for right triangles. Okay, and then there are several parts to both the theorem itself and also to the triangle, right? So the first thing is that we have the hypotenuse. Okay, the hypotenuse is always the side that is opposite of the right angle. Okay, so there's our right angle down there. So then that side that's opposite, or really the side that's not touching the right angle at all, is going to be the hypotenuse, which is always labeled C. Okay, and then we also have the legs, which are labeled A and B. And then those are the sides that make up the right angle and are also adjacent to the right angle. Okay, so there's those sides. All right, so real simple there. And then the Pythagorean theorem itself, okay, this is very important that you know, is a squared plus b squared equals c squared. All right, a and b are the legs, c is the hypotenuse. Okay. The next thing is the converse of the Pythagorean theorem, and guys, I know I'm going through this pretty quickly, so if you need to pause and take notes, feel free. But the converse is basically the same thing, it's just the other way around. So it's saying that if you have three side lengths where you can do a squared plus b squared equals c squared, and it's true, then you have a right triangle. All right? So in order to use the Pythagorean theorem, we'll just go ahead and jump into that. If we look down here at example 1, we have a equals 10 and b equals 5. All right, so the Pythagorean theorem, like we said earlier, is a squared plus b squared, not plus, equals c squared. Okay? And then we can go ahead and plug in our numbers for the variables where we have the opportunity, right? So a is 10. Right, I'm looking at example 1. I don't remember if I said that or not. But a is 10, and then b is 5, so we can put 5 in for b, equals c squared. And we get 10 squared is 100. 5 squared, sorry about that, 5 squared is 25. And then c squared just remains as c squared. Simplifies, so 100 plus 25 is 125. And last, we get rid of the square root, or the squares on both sides. By doing the square root, that makes those cancel. So we end up with c equals the square root of 125. And I'm going to leave it like that for this one. You could go ahead and round it, but we're going to leave it like this for now. So once you feel like you're comfortable with that problem, I want you to go ahead and try out example 2 on your own. Be aware that it's a little bit different, so your setup is going to be slightly different than that problem that we just did up here. And the reason for that is we're given B and C instead of A and B. Okay, so keep that in mind as you set this up. So pause the video, try it out, and then we'll continue on again. All right, so once you've done that, we're going to look at example 4. Okay, example 4 is a word problem, which I think is a pretty good one. We have an 18-foot ladder is placed 5 feet from the base of a wall. So let's say this is our wall, and here's our I guess the ground. And then here is our ladder. Okay, that's a perfect ladder. Don't question it, or else. Just kidding, but you can see it, right? That's a ladder. Here, we'll even put some grass, red grass, sure, but still grass, right? Okay, so how far up the wall does it reach? Okay, that's what we're looking at for this one. We got a nice window there too now. It's completely fixed up. All right, anyway, so the ladder is 18 feet. It's 5 feet away from the base of the wall, and we want to know how far it can reach up the side of the wall. All right, so it's important to recognize that this is our right angle first, right? Knowing that, we can go ahead and figure out which sides are which. So we use a squared plus b squared equals c squared. Okay. We know that the ladder has to be the hypotenuse, and the reason for that is it's opposite from the right angle. It's also the diagonal side. Okay, so there's a couple things telling us that. Now, it doesn't matter which side 5 is. We can do A or B, right? It's not going to make a difference. Okay, I'm going to put it as A, but again, it doesn't matter. So we have 5 squared plus B squared equals 18 squared. All right, and we get 5 squared is 25, B squared is B squared, and then 18 squared is 324. Okay, next we just need to subtract 25 from both sides. We get b squared equals 299. Take the square root of both sides. Those cancel. We end up with b equals the square root of 299. All right, and again, we can just leave it as is. All right, so I want you to go ahead and do example 5. It's just one more example, very similar to the one you already did, but I think it's a good idea for you guys to go ahead and practice a little bit more with it. All right, and then we will move on after that. Okay, so the next thing that we have is example 6 I want to look at. Okay, this is looking at the converse of the Pythagorean theorem. Okay, so for 6, we're trying to figure out basically if it's true or not. So you're going to plug in the 3 numbers to the Pythagorean theorem. So you have a squared plus b squared equals c squared. All right, the real important thing when you do this is to make sure your longest side always goes in place of c. Other than that, it doesn't matter where the numbers go with a and b, but your longest side has to be c. All right. So we then have 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. And 13 squared is 169. So then we add those together. We get 169. And of course, 169 is equal to itself. So that means this one is a right triangle. Okay. So for example 6, the answer is yes, it is a right triangle. All right, and then I want you to go ahead and try out example number 7 on your own, and then we'll move on from there. All right, and then we just have, what am I doing? We just have this one last thing to do for this video. Okay, this is just to review a little bit before our next video lesson, which is going to go into a lot more of this stuff, just more in depth. Okay, so our review basically, if you just want to look at A, and then I would also take a look at, I don't know, any of these. You can go with E. Make sure you understand how those work, and then after you do that, I want you to list out the first 20 perfect squares. I know I had you memorize the first 15, but I want you to go ahead and try out the first 20, see if you can get those. After we do that, that is it for the video. So get that done, and then I will see you guys in class.